In organic chemistry, functional groups plays a vital role in order to go for its pharmacopoeia activity or else using in the industrial application, namely organic paints it might be, or else polymer chemistry you're going for, materials you're going to synthesize, ceramic industry, and any mechanical properties containing material, high strength applications, under photolytic conditions, thermal conditions, electrolytic conditions, if you're operating in most of the regions wherever you are aspiring for, you are going for, organic functional groups plays a vital role, highly applicable type of compound, and most of the research, chemical research purely rely on these organic functional groups and their transformations and enhancement. That's the reason why learning about organic functional groups plays a most important role in a educational platform as well as research platform. Alkane is simply said to be a carbon-carbon single bonded compound, and all bonds are said to be singly bonded and called as sigma bonds, called alkanes. Ethane is the simplest example under this category. Alkane is a carbon-carbon double bonded where you can find one sigma, one pi bond over there. So the double bond if present, you can say alkene. Ethane is the common example. Move on to alkyne, you can find a triple bond over there. One is said to be sigma and two are called pi bonds. Ethyne is the example under this category. Alcohol where OH is present, that is called hydroxy. Alcohol and ethanol is the example, typical example under this category. And another organic functional group is the ether, ROR is the general representation. Methoxyethane is the commonly available example over there. Epoxide, whenever cyclic compound is there where you can find carbon-carbon bonded with another atom with the cyclic manner. Ethene oxide is the example for epoxide, oxygen bonded with the two carbons under cyclic conditions. Haloalkanes, any halogen which directly bonded with the alkyl. Chloroethane is the example for haloalkane. Aldehyde, you can find C double bond O and another hydrogen bonded to carbon. So that aldehyde is named. Ethanol is the example. If you are placing methyl, CH3 C double bond OH is called ethanol. Ketone, where you can find the difference over there. If you are having RCH, so that aldehyde, RCR bonded with double bond O, where you can find ketone. Propanone is the example over there. Carboxylic acid, where C double bond OH is present, carboxylic acid you have to pronounce. Carboxylic acids are the organic acids which are strong in this category, organic point of view. Acid anhydrides, which are taken from the carboxylic acid, wherever carboxylic acid dehydrated, converted into anhydride form. And one more is the ester. Ester is the fruity smell containing a liquid moiety. Ethyl ethanoate is the example. C double bond O, R is general representation. If you go with C double bond NH2, this is also acid derivative. This is called amide. Ethanamide is the best example. If you substitute CH3, C double bond NH2, which is called ethanamide. Acyl halide is CH3, C double bond Cl. It is also the acid derivative, CH3C double bond Cl. If you are placing ethanoyl chloride, you have to pronounce as per the IUPAC nomenclature. RNH2 is called amine, and here NH2 is the functional group which is designated as amine. Ethanamine is the best example. You have to place CH3, CH2, NH2 over there. RC triple bond N is called nitrile. Cyano functional group, we can say it is called nitrile. And ethane nitrile is the general example where you have to place CH3 because this carbon also accounted for the naming. So that just CH3C triple bond N, we have to say ethane nitrile. This is said to be what oxime, and carbon nitrogen double bonded compound is called imine. So any single bonded nitrogen is called amine. Wherever double bond is there, called imine. Ethanamine. Ethanamine is the example over there. Isocyanate, whenever nitrogen doubly bonded with carbon, doubly bonded with oxygen, which accumulated double bonded system is called isocyanate. This is the typical intermediate in versatile named reactions. We can find much applications over there with this isocyanate intermediate. Ethyl isocyanate is the example over there. N double bond NI is called azo compound, where azo functional group is the most common in dyes, pigments, or coloring matter. Intensified coloration is available whenever nitrogen-nitrogen double bond is located. Azoethane is the example over there for these compounds. SH if present, that is called thiol. If OH is there, called alcohol. Oxygen if substituted with sulfur, that is called thiol. RSH is the thiol general formula. And if you are placing CH3 over there, we can say methane thiol. This is the way organic functional groups are mentioned. Hope this is informative session. Thank you.